This lesson is on variability in box and whisker plots. Variability, think about what that word sounds like. Vary. How does your data vary? It's used to measure how basically spread out the data is. Range would be something that we have that helps us to look at how spread out our data is. And you guys know how to find the range. It's the largest value minus the smallest value. A box and whisker plot is a certain type of graph, a chart, that's going to help you to see how spread out the data is, or the variability. This is an example of a box and whisker plot. The box and whisker plot is made up of 5 key values. So the steps to finding those 5 key values, you're going to start by number 1, putting them in order from smallest to largest. And then the 5 key values are the minimum, or the smallest number, the maximum, the biggest number, and then the 3 quartiles in between. So what are these quartiles? Well, you already know one of them. The second quartile is really just your median. What is the median? Remember, median is the middle. So it's the middle value of the data. So what you're going to do is you're going to put the list of numbers in order from least to greatest, and you're going to kind of cross out until you get to the middle. That's your median. Then the first and third quartiles are just the middles of the lower half and the upper half. I'll show you what I mean by this. Once you have those 5 key values, you draw a number line like I have in my example here showing the test scores, and then evenly space out the numbers, and then you draw a box in the whiskers. I'll show you what I mean. You can refer back to this first page though for directions on how you're going to create your box and whisker plots if you are struggling. Okay, so let's look at example 1. Construct a box and whisker plot with the following data. The USC baseball team scored these amount of runs in their past 10 games. Okay, so step number 1, what did I say? First, you need to order these numbers from least to greatest. All right, so I'm going to put them in order here. 1, then 3. Maybe cross them out as you go so that you don't lose track of where you are. There's 2 5s, so we have to list it twice. There's also 2 8s. Don't forget this 10 after the and a 12. I like to count them just to make sure I have the right amount. So if you count them in the original typed problem, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then count them in your list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It seems like a small unnecessary step, but it will help you to make sure that you haven't missed a value. All right, so now that they're in order, you're going to find the 5 key numbers. I'm going to make the list of the key right next to it. Our 5 key numbers are going to be the minimum, Q1, Q2, and I'm doing this as a little subscript, Q3, and then the maximum. All right, so here's my key set up. Minimum and maximum are easy. When you look at your list, your minimum is 1, it was the lowest number, and the maximum is 12, it was your highest number. Okay, so you're always going to find Q2 first. What I would do is I would kind of mark or dot each number as you go across the list. So 1 and 12, 3 and 10. I'm just going back and forth. I'm trying to find the middle value. In this case, the middle value would be right in between 5 and 6. If one of your data values is not the Q2, there's an even number here, right? So we have 5 numbers on each side of our middle. Then what you're going to do is find the average of those 2 numbers that it's in between. So to find Q2, you would be doing 5 plus 6 divided by 2. You can probably do that in your head, or just think about what that is. What's right in the middle between 5 and 6? It should be 5.5 or 5.5. 5 plus 6 is 11. 11 divided by 2 is 5.5. Okay, so since our Q2 was 5.5, It was right here in the middle. I'm going to circle that 5.5. I'm not going to use that for anything else. Now when I go to find the Q1, I'm looking for the middle of just the lower half. I'm looking for the middle of these 5 numbers. I do include the last 5 there. So I'm going to start crossing it off here, or marking it. I like to use a dot. So 1 with the 5, 3 with the 5. 4 is a middle value, so 4 would be our Q1. Now I'm going to look for my Q3. That is my middle of my upper half of the data. So again, 5.5 is not used because it wasn't actually a data value. That's what our Q2 came out to be. It was in the middle. But since it's not actually one of the data values, you don't use it when you're now looking at the upper half. So I'm going to start at 6 and go up to 12. I'm looking for the middle of that. You can cross them out. You can dot them. 6, 12, 8, 10. The middle over there would be 8. So my Q3, or my third quartile, is 8. Okay, so we have our 5 key values. We're going to make a number line. We're going to try to evenly space our numbers. You don't have to start at 0. You can if you want to. In this case, we need to at least show as low as 1 and as high as 12. So I'm just going to start at 1 and go to 12. Since it's 12 tick marks, I can probably do them all out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to extend that little arrowhead out just a touch more so that it can fit. There. All right, you could number each of those then, showing what they stand for, or you could, I'll do that right now. All right, great. So our 5 key values are all going to be points above this number line. I'm going to try to line them up. So 1 is a key value. 4 is a key value. 5.5 will be right between 5 and 6. Put a little dot there. That's a key value. 8 is a key value. And 12 is a key value. Okay, so there's your 5 key values. All right, so the minimum and the maximum are your whiskers. The box is made by the quartiles. This is called a box and whisker plot. So you connect, and notice I'm going to let that dot kind of be in the middle there. You connect your Q1 to your Q3, and you also draw a line through your Q2. So this is Q1, this is Q2, and this is Q3. You don't actually have to write those on there, but I'm just trying to help you see where we make it. The quartiles always form your box. The whiskers then connect your maximum to Q3 and your minimum to Q1. Again, you don't have to have these labels. We have the key next to us, so we don't need them, but this is the first one you're seeing, so I'm trying to help you out. This is a graph, guys, so you can always title your graph. This would be USC baseball, runs. And this kind of demonstrates that how spread out their scores were from the game. So we can see that they had a game where they had 1 run, they had a game when they had 12 run, and a decent amount of their games have, between 4 and 8 runs. Actually, the quartiles are the medians. So that's like the middle. It divides the data into 4 equal parts. So this box and whisker is done. I don't want you to write anything else. But the quartiles break up your data into percents. If you think about it, if you break something up into quarters, what percent do you have? 25%, right? So actually, 25% of the data is in each section here. Oops, I didn't want to do that in the big one. Let me come back here. So 25% of the data is between 1 and 4. 25% of the data is between 4 and 5.5. 25% of the data is between 5.5 and 8, and 25% of the data is between 8 and 12. That's why we call them quartiles. So 50% of the games the USC baseball team had between 4 and 8 runs, including those amounts. 75% of their games, they scored more than 4 runs, 4 or more runs. So I can kind of get that information by knowing that these are quartiles. If you just saw the box and whisker plot, you wouldn't necessarily know exactly how many runs they had in all of their games. It just gives you an idea of how spread out this data was. Okay? All right, again, let's try another one. Construct a box and whisker plot with the following data. The USC Library orders new books every month to replace copies that were damaged. These are the number of books they needed to order these past few months. Okay, first step, you guys know it. We're going to put these numbers in order from least to greatest. That will help us to find our 5 key values. All right, so the lowest number I see is 7, then 8 4 times, then 10, 15, 19, 20. Perfect. 10, 15, 19, 20. Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9. Okay, so since there's 9 values, think about this. We're not going to have the problem that we had last time. There will be one data value in the middle. Set up our key to find our 5 key values. We're going to remember it's the minimum, Q1, Q2, Q3, and the maximum. The minimum and maximum are nice and easy from your list. The minimum is 7. The maximum is 20. The Qs stand for the quartiles. Remember, those quartiles are the medians. Q2 is the median of the entire set. All right, so you can cross them out. You just want to do it with a light color so you can see through it. I like to do the dot above it. 7, 20, 8, 19. Keep going. You will have one number in the middle. 8. Circle it. You want to circle it because you're not going to use that 8 to find Q1 or Q3. So since this 8, the fourth 8, is actually Q2, you're not, circle it, you're not going to use it to help you find Q1 or Q3. All right, so ignore that 8 now. Now for the lower half, for Q1, you're looking only from 7, 8, 8, 8. All right, so again, it's like 1, 1, 1, 1. Oh, it's going to be right in the middle there. Well, guys, what's right in the middle between 8 and 8? You don't need to find the average. You could. 8 plus 8 is 16. Divide it by 2. That's going to be 8. What's right in between 8 and 8? Just 8. All right, now we're going to find Q3. Q3 is the median or the middle of the upper half. So from 10 to 20. So we do 10, 20, 15, 19. What is right in the middle between 15 and 19? You can find the average if that helps you. 15 plus 19 divided by 2. And think, what is right in between 15 and 19? 15 plus 19 is going to be 34. 34 divided by 2 is 17. Or you could probably visualize that 17 is equally in the middle between 15 and 19. Okay, so now we have our 5 key values. What are we graphing here? We are graphing USC's library book replacements. All right, we need a number line for our box and whisker plot. So this has to go from 7 to 20. Maybe I'm going to count by 2s on this one. So I'll start at 6, 8, 10, 12, 14, 16, 18, 20. Just making sure it's going to fit before I write all those numbers on there. Go at least to your lowest and your highest numbers. Okay, remember, we put the dots now for our 5 key values. Your minimum is 7. It's going to be right between 6 and 8. Ooh, this is a trick here. This is tough. Q1 and Q2 are both at 8. So when I go to plot that point, I'm really not going to see 2 points there. There's just 1. Q3 is over here at 17. And the maximum is 20. So this is a little unusual. Probably more often you do see 5 different key values, like in example 1. Example 1 showed you a typical box and whisker plot. Example 2 here is showing you what can happen though, because students always have questions when this comes up. You can end up having Q1 and Q2 be the same. In that case, you're going to still have the box connecting the quartiles. You're just not going to have the line representing the middle of it. It's really actually like that line is over here on the left side again. This is actually your Q1 and your Q2. Your Q3 is over here. You can put those labels on it if that helps you, but you have a key right next to the box and whisker plot, so you don't need to have them. Usually your box and whisker plot has 5 different key values, but it can happen that they are not 5 different values. In this case, you just have a box. You don't have a divide line in the middle of that box. It could also happen that you end up not having whiskers, or you end up not having, the box and whisker could look a little different. Let's keep in mind that these are quartiles. It's still broken up into 4 quarters, all right? So 25% of the data, I don't want you to write this, but 25% of the data still lies above Q3 and below the maximum in that range. 25% of the data still lies right here in this tiny whisker. So actually, what percent of the data lies between Q1 and Q3? This box is representing 50% of the data, right? That shows us that there's a cluster of values down around 8. And that kind of shows us the distribution here of the numbers. Again, you don't have to write the percents, but they are quartiles. They're breaking the data up into quarters. Okay, so let's analyze box and whisker plots. What if I gave you the plots and I asked you to come up with answers here? Answer the following questions based on the box and whisker plots below. What is the median test score for first period? All right, so when you look at first period, remember those 5 key values. What represents the median? The median would be the Q2. That's going to be right here. What's the median test score? 80. Compare the range for each class period. All right, so how do you find the range? Remember, range is maximum minus minimum. So for first period, the highest test score looks to be 100. The lowest looks to be 60. 100 minus 60 is 40. For the second class period, highest minus lowest, maximum minus minimum, 25. Compare, so let's make a statement here. I would say first period has a larger range of test scores than second period. Good, last question here. What percent of each period scored below a score of 80%? This question connects back to those quartiles that I was talking about. So what percent is below 80? So look, here is 80 for both periods. What percent of each class is below 80%? Remember that the quartiles break the data up into quarters, or 25%. So take a look. There's where the quartiles are. I just highlighted them in green on the chart. Well, what percent of period 1 is below the 80? If I look at period 1, I have 25% here and I have 25% here. So 50% of period 1 scored below an 80%. Does everybody see where I'm getting that? Keep in mind it's 25%, 25%. Each quartile breaks the data up into 25%. That's how I got the 50%. So what percent of the class of period 2 is below an 80? Well, there's only one section there, so that's 25% of period 2. I hope this helps with box and whiskers. Ask your teacher if you still have questions.